So, hi everyone. Thanks for carrying over this. It's going to be interesting to see how we're going to do demos now, as my main machine is still in a hypervisor green screen of death, as it is on Windows these days. And I probably need to have the Q&A going on this different machine over here. So. As we get going, I'll go and check the Q&A as we go along and the chat, because I can only right now see the slides. But let's go ahead with this. Okay, my name is Mikkel Hegnhoj, and I'm one of the program managers in the Azure application platform team within Microsoft. I've been with Microsoft for the last 9 years and done a lot in the space of developer tools for the cloud, container tooling for developers, and also some of our container services or microservices-based services in Azure. I've been working a lot with Service Fabric and also with Kubernetes and AKS. Very recently, I headed bringing Windows containers to general availability inside AKS. And today, we're going to talk about Azure Arc. And there's some contact information here in the slide. Feel free to reach out after this session or anytime if you want to engage. If you have any questions you want to help with. So the session is going to give you an overview of Azure Arc, what that is. I'm going to dive a little bit more into Azure Arc for Kubernetes. So Azure Arc is made up of 3 different types of Azure Arc or Azure Arc flavors that we have today. It says demo. I don't know. Let's see how that goes. I can probably show you something real, and we can talk about those concepts. Maybe have something a little bit more interaction session at that point. Close down on a few customer key scenarios, and there was probably going to be time for Q&A in the end, but also hopefully as we go along. So I am just going to see how this is how this is going to go. Okay, so this is the Q&A that I have to monitor, so I probably have to go and switch back and forth a little bit. So what is it that, why did we build Azure Arc in Azure? Well, we know that there's a ton of application requirements that are evolving over time. Like from an infrastructure or an operational point of view, if you're an operator that have to operate a certain set of applications, it's not just a single or few applications these days. You have to deal with operating tens, if not hundreds or even thousands of applications. They can be hosted across virtual machines. They can be hosted in serverless offerings, use containers and databases. And they have probably been built with a large variety of different frameworks and programming languages that you've used. You probably also see these applications being deployed across a diverse set of infrastructure. So that could be different data centers. It could be different hosting providers. They can sit on different kind of hardware, or even IoT devices, or be at the edge in some shape or form. And finally, if you move into the public cloud space, we have a lot of customers and need more and more customers who are deploying applications across different cloud providers. And there might be various reasons why you wanted to do that, but they end up being, you end up having an operational role inside your company that has to deal with all these things. So the problem you're faced with is, how you're going to govern and operate across all these different environments, and how can you ensure something like security across those, and be able to quickly, innovate and still develop agility and deliver business value at a high cadence. All these kinds of problems we see exist today. So this is, if you think about how Azure has been built out over time to give you a better support or a broader hybrid story, we have everything from, Azure Stack being sort of the integrated form factor that gives you a combined hardware software solution that you can go and deploy in place in your own data centers, or we also see these in, let's call them edgy data centers or mini data centers in different places. And on the other side, you have things like IoT, which is really, Azure IoT devices or devices being deployed typically outside of data centers environments, either whether it is in some kind of vehicle moving or whether it's in building to monitoring or stuff like that. And right in the middle, we have this thing, we have Azure Arc, which is there to sort of help bridge all of these, or fit in the middle of these scenarios where you don't need to have a specific set of hardware that we can run, or you don't need to have a specific set of deployment for us to support. But it's really there to help you, to help support run a certain set of services and applications across any data center and across any cloud. And the main focus in all of this from Arc side of you is to bring some of the great Azure management capabilities to all these data centers wherever they run. So what we do with Arc is we bring Azure management services to any infrastructure. We extend the management across all these different environments. We help you to adapt cloud practices to on-premises environments. And we're going to do a little bit of deep dive into GitOps later, which is one of the key components of Arc in terms of how we help run Kubernetes. And it also helps, how you can implement Azure security in all these environments. So basically, it takes and extends the management experience from Azure to your on-prem or to your infrastructure anywhere. So the way that this works is, if we sort of try to unwrap what all this means when we talk about Azure management capabilities, let's start by taking a look at how Azure management works today. So if you think about Azure management as sort of being the single control plane across all the different Azure resources you can deploy inside Azure, then if you look on the far left-hand side here, we have all these Azure customers using a set of tools and experiences. So whether that is through the Azure portal, through any shell, PowerShell, whatever you're using there, and across the different, client libraries of client scripts that we have, with Azure CLI or some of the SDKs. So there's a whole set of tools and experiences that sort of help you bridge into and manage these things. And when you use these tools and experiences inside Azure, you talk to the thing we call the Azure Resource Manager. And Azure Resource Manager, or ARM for short, is sort of the main entry point inside Azure. And it has a lot of great capabilities that customers use when they run and structure and operate their Azure environments today. So anything from access and security concepts to do role-based access control on the resources, and things like subscription hierarchies and how you can organize all these individual resources that you pay for, and organize and do inventory around, you can search through them, you can group them via resource group concepts, and you can also do a more loosely coupling through using tags across these resources. You have things for environments and automation with templates and extensions, and governance and compliance. You can go and apply into this by using things like blueprints to sort of wrap around a set of deployments, or look at your logs, such as the policies that you can go and enforce on top of all these resources. Now, the Azure Resource Manager then talks to the Azure resources through what we call the Azure Resource Providers. So each and every resource that we have in Azure, and each and every service is exposed through what we call the Azure Resource Provider, or the RP, as we typically talk about them. So whether you are running a virtual machine, whether you want you're running websites and app services or functions, whether you create Service Fabric or Kubernetes clusters, or any of these resources you create in Azure, they're all represented by resource provider, and they all have to, each individual resource provider have to adhere to a certain set of capabilities, so that all the Azure Resource Manager features and management features can actually be used on top of these resources. And on the very top of this, we have the management services. So this is the sort of the special set of Azure services that are not, they might be resources themselves, but are more meant to help you to bring even better management across these resources. So that could be things like monitoring, updating, backup, security center to help you, monitor and stay compliant across all these different resources, and many, many more. Now, with Azure Arc, what we're doing is we're taking all the layers of the Azure Resource Manager and the management services on top, and through sort of this, connectivity or connecting, I don't know what to call it, the Azure Arc interconnectivity thingy, we are now able to bring resources from outside Azure under the sort of the same unified control plane to give you that great, everything from the great tools and experiences through the capabilities of the Azure Resource Manager and the management services, and basically bring them anywhere. So Azure Arc comes in 3 flavors today. we have Azure Arc for servers, we have Azure Arc for Kubernetes, and we have Azure Data Services on Azure Arc. They're all in preview. That's the current state of the service. I actually think Data Services is still in a closed or a private preview, but it's definitely there on our docs exactly what state these services are in today. But Azure Arc for servers, just to give you a brief overview of the difference between these three types of Azure Arc. So Azure Arc for servers gives you the capability to apply a set of policies and pick logs and monitor any set of VMs you can have anywhere. So whether it's Windows or Linux-based VMs or whatever you can think of, you have in those data centers, there's a certain set of agents we can go and deploy and sort of bring them into the same management capability as you have in ARM. With Azure Data Service, what we provide there is we provide the ability to run a set of the Azure Data Services on a Kubernetes cluster deployed on any infrastructure anywhere. So Kubernetes is one of these things that we in Microsoft believe is a good place to meet across different providers in terms of how to bring a unified API across different places. So data services is a thing where we can go and deploy stuff onto Kubernetes. And of course, Azure Arc for Kubernetes is then the thing that will help you not only deploy applications and run applications on Kubernetes anywhere, but also manage and monitor and config and apply policies on top of your Kubernetes clusters. So if we dive a little bit deeper into what Azure Arc enabled Kubernetes gives you of capabilities, then I talk about how we can organize an inventory, not just the Azure resources, but also across our different environments. So with many customers starting to run Kubernetes and standardizing on that as their as sort of the operational or the infrastructure piece of their environments, what Azure Arc enables you to is to look across all your Kubernetes implementations that you have, on-prem or in Azure or anywhere else, and help you, organize and apply, policies and monitoring configuration across all these clusters. So there's really the ease of doing at-scale application management here, where the same set of applications and the same set of application configurations you can go and apply across all these clusters, no matter where they run. And finally, with the with the policy-based management, it's easy for you to ensure consistency. And this is where integration with a thing like Azure Policy and how Azure Policy uses another open source component called Gatekeeper, part of that being a thing called Open Policy Agent. Those are basically open source components you can go and run inside any Kubernetes cluster, and they can help enforce a set of policies in terms of what you can go and deploy onto these clusters. Now you're able to control those policies through Azure Policy, and through that common Azure management layer, you can now apply a set of common and consistent policies across your Kubernetes clusters, no matter where they run. Okay, this is going to be the demo piece. This is going to be what's going to be extremely interesting. I just need to open a quick checklist I have on my other screen over here, which I all just had to get up and running. And I'm not sure I have all my connectivity to all my clusters, but let's see how far we can get. Let's go and check on the Q&A and see if there's a thing going on in the chat. Mostly yes, yes, hi, all good, yes, yes, woohoo. Okay, sounds good. We're all good. Let's go to the Azure portal. No, let's go somewhere else. Let's go to the, let's go and find the Azure Arc documents. Now, had I been running on the machine I set up for this, I would have already had these tabs open. This was not part of the experience. Okay, so let me see. This is where we got into. We probably got into Azure Arc for Servers. That's not what I want. So the Azure Arc documentation that we have, and this should be the one. There you go. I need to go back. Zoom, zoom, zoom. there's limited but good documentation to get you started on using Azure Arc and on Kubernetes. And basically, there's a simple set of how-to guides here that walks you through the different operations you would want to do on your clusters in order to connect existing clusters into Azure Arc, using GitOps, using things like policy and monitoring and things like that. So because, I mean, we do support running Azure Arc across any set of infrastructure, any set of hardware that you have. But there are, of course, a few requirements in terms of having network connectivity. And all of that is documented here. And I think there might even be a few requirements in terms of the Kubernetes versions that we support. But all of that is fairly well documented. So make sure you look out for those small culprits as you go along. The fact that we only, it's funny here, the fact that we only support Arc in these regions, that's basically where the Azure Arc. So you can say if you go and connect a Kubernetes cluster into Azure Arc, we sort of have a resource in Azure that represents that Kubernetes cluster. That resource needs to sit in one of our regions. This doesn't mean that you can only, I mean, you can definitely, you can add clusters outside of West Europe and East US to Azure Arc. I just didn't want to make sure, just want to make sure that there were no confusion there. Okay, so let's go into the Azure portal and see what this experience is going to look like. And we're still waiting for the Azure portal. Patience timed out. Let's try again. There you go. Okay, I'm just going to zoom in a little bit more here so it will be easier for you guys to see what's going on. I have no idea. Well, let's stick that over there. Okay. Inside the Azure portal, we have Azure Arc. Now, before you can actually use Azure Arc, you need to go and register for the preview. There's a set of providers you go and register. I think that is also fairly, yeah, that is all fairly well documented here. So it's a self opt-in. You don't have to be signed up and accepted and so on and so forth. So even though it's preview, you can still go and try it out. I've already done that. And as you can see, I already have a few clusters connected in here. And the way that we present this to you inside Azure Arc for Kubernetes is that we actually take both the AKS Kubernetes clusters, so the Kubernetes clusters that you are running inside Azure, where you use the Azure Kubernetes service to provision these clusters, are going to be shown here as part of Azure Arc, together with other Azure Arc enabled Kubernetes clusters. You can see I have one here, which is basically a Kubernetes cluster that I stood up on my own and ran somewhere. For all practical purposes, this cluster is also running in Azure, but please just disregard that for now. It's not an AKS cluster, it's a DIY cluster we built inside Azure. So you can see I have these clusters here, and the reason why that we connect both the AKS, or we show both AKS and also these Arc connected clusters in here, is because that the kind of monitoring and policy, and when you go and apply policies to these, and eventually also how you deploy through configuration, you can go and apply that across all these clusters, irrespective of how you got the Kubernetes cluster. Whether it's run in, in Google's Kubernetes engine or Amazon's Kubernetes engine or through AKS or a Kubernetes cluster you ran anywhere, they're all going to be Azure Arc connected Kubernetes clusters. So if I wanted to go and connect the cluster here, I can go and register a Kubernetes cluster with Azure Arc, which basically means I'll go and take an existing Kubernetes cluster and add it to Azure Arc. I can also add a Kubernetes cluster that will actually set up an AKS cluster for me. So what happens inside the portal, and this is of course a little bit strange because there's nothing we can do from the portal to sort of get a hold of the Kubernetes cluster, at least not yet. But what we can do is we sort of have a small guide that helps you, guides you through this common Azure experience we have at how to create Azure resource groups. You can say you want let's say I have a 115 cluster somewhere. And basically what we give you here, then we give you like 3 easy commands that you would have to run against your Kubernetes cluster that's already set up for it to go and attach into the Azure cluster, into Arc, sorry. So basically all I'm doing here is I can download a PowerShell script, I can download a shell script of this, and all I'm gonna do is I'm gonna log into Azure, set my account up, and then we're gonna run this AC connected K8s connect command and say that against the Kubernetes cluster that I'm connected to from within my shell session, it will now go and connect that into this Azure Arc resource that I have. This is where I wanted to have started a terminal and actually ran that command on a cluster, which I cannot do. I'm very sorry for that. But after I've done that, you can go and verify that the connection actually set up, and we will see a green mark here, and you can see that the cluster is connected. Now, what happens when we do this is that we are going to run a set of run a set of deployments against the Kubernetes cluster. So the only way you can attach these clusters is by having them being connected to the cluster and having the access right to go and deploy all the components that we need. So basically, the set of agents that we run to connect back to the management endpoint in Azure. And then there's a bunch of other components we install to enable some of the capabilities we have in here. So let's look a little bit more about these capabilities, what they are. So what I'm looking at right now is an Arc connected Kubernetes cluster. So this is a Kubernetes cluster I set up on my own, and I've connected it to Arc to give me this great management experiences. And there's a few things I want to show in here. First of all, I want to show you how policies are applying to these things. So what you can see here, if you're familiar with Azure policy and how that works, you can see there's a bunch of policies that are being applied to my Kubernetes cluster based on how these policies were defined in terms of their scope. And the scope of these policies would then be within inside the Azure resource hierarchy. So for instance, there's probably some of these policies down here where let's go and unwrap one of these, where you can see that it has a scope. This is basically the scope for this policy is my whole subscription. So any resource within inside this subscription is going to have this policy applied, and policies can then go and either do automatic remediation, or they can just go and report. So basically you can take a report and see which of your resources are compliant and which are not, and you can go and remediate those manually if you wanted to. And again, these policies that I have here now and which are now applying to my Arc connected Kubernetes cluster are also applied to my AKS Kubernetes clusters. The next thing I want to show is monitoring and how we use Container Insights or Azure Monitor to monitor these Kubernetes clusters. So what you see here is you see the monitoring agents that I run now inside this Arc connected Kubernetes cluster. And you can see how we're reporting node CPU back. We're reporting consumption on the individual nodes. We can even go and see the individual containers that have been deployed here. And all of this is actually coming from a Kubernetes cluster that could have been deployed anywhere. And what I quickly want to jump over to here is to show you how, let me see, I'm probably gonna go all the way over here. How, if I now go into my AKS cluster, which is the cluster that is, which is an AKS, which is an Azure Kubernetes Services cluster, a cluster that we stood up in Azure for you, where we run the master service and stuff like that. It's the exact same monitoring experience you get. So the fact that you have, the unified control plane across the AKS clusters and those on-prem, you see the same graphs, the same node CPU utilization. You can go and dive into container, CPU, and logs here as well as you could have those Arc-enabled clusters. And basically what's happening on the Arc side is that we're running the same set of monitoring agents inside your on-prem Kubernetes cluster that we would have done, or that we do inside this AKS, the Azure Kubernetes cluster. So the last thing I have in here is configurations. And configurations is, we call them configurations, but it's really, we also call it GitOps integration. It is a way for us to go and apply workloads that could also be configurations across these Kubernetes cluster. Now this today is in the form that you see here is an Azure Arc enabled or Azure Arc enabled Kubernetes clusters feature only. We don't have this for AKS yet. But since this is built on a set of open source tooling, you could go and apply the same concept to AKS. but we will be bringing the same experience to AKS eventually. I think there's already a preview and a few preview docs out there on GitHub that will show you how to do this. But let me head over to the slides and let's talk a little bit more about what this, what GitOps means. Before, let me just do a quick check-in on the Q&A and live chat. We're still good. Okay. So GitOps is, by definition, is running a kind of running an operations on your clusters where you use Git as the sort of truth for system. Like Git is going to be the single place where we do all operations, the create, change, and delete. And because the way that Git implements things like pull requests and versioning and all these versioning through commits, we see that all changes are observable. Now, this is the principles. Then the principles behind GitOps is that, you know, all the system state that we have is described declaratively inside our version control. Whereas it is stored, and the current state of the system is there. And through, you know, pull requests and the processes we can set up around these, there is an integrated approval process to all the changes that we make. And then eventually we have a set of agents that are deployed inside our infrastructure who are going enforcing the desired state that we describe through the declarations that we have in our source code. So it's funny because to me, I used to do a lot of operations, a lot of infrastructure focused, and you know, and I remember probably many years ago, but still, you know, there's been all this talk about infrastructure as code. This is basically it, but it was developed by developers. Like that's, I don't think that's too, that's one way of putting it. So now it is Git. Git is the place where we do our infrastructure as code, and through GitOps, we don't necessarily use pipelines to push these changes out. We have agents that go and pull them directly when they're submitted in source control. So you can think about it that way if you are more coming from that side of things. What we do in Azure Arc is we've implemented Flux, which is an open source GitOps set of operators, which was developed by Weaveworks, and which is now, Flux is now moving into the Cloud Native Foundation, Cloud Native Compute Foundation. I think it's currently a sandbox project there. So Flux is on a sort of a path with a lot of other these open source projects to be part of the broader Cloud Native Foundation, Computing Foundation work. But we have taken Flux the way it is and integrated into Azure Arc. So we're using that as sort of the core infrastructure of this, which means that if you run Flux today in a Kubernetes cluster, there's some of the concepts in Arc and how this works that would be very familiar to you. So the way that a workflow would work inside GitOps is, you know, from a developer's point of view, you go and write your app code. There'll still be some CI pipeline that will make sure that we do our builds, we do our tests and our validations and all these things. And eventually the set of container images will be pushed to a container registry somewhere. Then when you want to go and deploy these things, what we do is then go back into Git, and we see that we have a set of application manifest that we can now go and update. And as we go and update our application manifest, we will see new pull requests being submitted against that repro. And going through the pull request approval process, where people can go and comment and you can ask for approval and all these things. Once the PRs get merged in and there's an actual commit changing the source code, the Flux agents running inside the Kubernetes clusters will go and pick up these changes and make sure that, you know, all the resources and deployments are being transformed into the state that is now declared inside your Git repository. And it basically looks like this. The main thing to take away here is that what you want to get away from is you want to get away from having the manual kubectl apply or the manual apply operations directly against the Kubernetes API. You really want to have the Flux operator taking care of all of this so that it's always in sync in what you have inside your code repository, so that you have the history of the commit messages there. Now, this opens up a lot of interesting scenarios where if you want to do these kind of configurations and you have multi-tenant setups, you can go and describe these Flux configurations and deploy them into multiple, either multiple namespaces inside the cluster, the same clusters, or across, or in the same configuration across a lot of different clusters. So if we head over to the portal here, let me get back to the QA in a second. When we head over to the portal here, you can see that I've already added a few configurations to this cluster. So I have this voting application that I've deployed, and I'm sorry that I don't have a connection set up to my clusters on this machine, so I can't go and show you what's actually running inside Kubernetes. But what I can show you is if we go into one of these configurations, you can see that this is, we actually do have the GitHub path here. What this configuration is doing is I basically told it to go and look at this GitHub repository. And within this GitHub repository, there is a path called releases/prod, and then go and deploy that as the Azure voting app into the prod namespace inside my cluster. So if we look at the Git repository here, what you will see is that inside this releases/prod folder that I have a single YAML file. And in this case, what I'm using here is I'm actually using Helm as the deployment operator mechanism inside Kubernetes. So let's say that I now wanted to update this deployment that I have. Because I have the configuration set up to my cluster, all I would have to do is go inside my repository. Let's see, there's a v1.2 coming out, and for some reason I want to change the replica count to 2. I can go and do that. And now I could actually, which I should not, I could commit it directly back to my master branch, but I could also create a new branch and say, hey, this is the upgrade to version 1.2 that we're going to have. Change to 2 replicas for too many. Updating. So basically now we're going to have a new branch. It's going to be set up. We're going to have a pull request. Please verify and approve. Now I could have, if I had any friends in my repo, which I don't, I could have called them out here. So let's call myself out. And basically a pull request is now open. So the change that I've proposed to our infrastructure and how our application is running is now sitting here in a pull request. And if anyone goes in and starts reviewing, they can see what are the actual file changes happening. They can say, well, let's stick to 3. And then they can go and say they want to start a review. And basically they can say that this is, I can only comment. Okay, but they could eventually have said that they would have liked those changes to come in before you actually committed. And once the PR gets closed, the new state or the desired state of this application to run version 1.2 and 2 replica counts is now going to be picked up by a Flux agent and is then going to be deployed to this cluster. So you can easily imagine once you have these configurations set up and running across multiple Kubernetes clusters, it's very easy to have these applications defined as configurations, and then through your Git repositories, you're able to push out an equal configuration or an equal state of those configurations across a large set of deployments of your clusters anywhere. Okay, so let me see if I can go and find the Q&A thingy. Here we go. If we have a GA date, I don't have a GA date at this point in time I can disclose, but please follow along with our preview as we go along. There are still some rough edges to be fleshed out here. So currently GA is pending. We don't have a date we can talk about at this point. And there's still just a bunch of hellos over here. Okay. Oops, I closed it. I don't think that was. Oh, okay. More questions coming. How does Azure Arc compare to Outpost and Google Anthos? So the main thing is that we don't require any specialized hardware or setup on your side. I mean, any Kubernetes cluster, anywhere it's running, you will be able to go and enable these through Azure Arc and then get these great capabilities in terms of logging, configuration, and policy deployments. So the only thing that we require is that we have connectivity from your Kubernetes clusters into the Azure management endpoints. And of course, there's a certain set of requirements on what versions we support here. And it's the same with Azure Arc for servers as well. And the other question is, are the Flux CD features available with Azure DevOps CD or any plan to have those? If you run Git source controls, I've never tried this, but I'm pretty sure if you have, Flux should be, Flux would support any Git-based source control system. So if you're using Git in Azure DevOps as the source control system, you should be able to also connect Flux to that as well. So that's the main. So any Git-based Git-based system would be able to do that. There are some edge cases of authentication that we currently don't support, but again, those are also fairly well documented on the documentation side and how you set those private connections up between the Arc clusters and your Git repositories. Okay, so to give you just a quick schematic overview of this, so on the Azure side, what we have is we have this config and connect service for your Kubernetes clusters. And then on your cluster side, you can see we run both the connect agent, we run a configuration agent who talks together with this locally deployed GitOps manager, which is where we go and deploy the different applications and configurations from. In the case where you run monitoring, you have operations manager, you have the OMS agent installed, the Azure monitoring agent installed that is going to push all the telemetry and the monitoring and metrics back up to Azure and into Azure monitoring. So this is from the customers, from your data center point of view. We need configuration when, from the config part, we need configuration from config and policy. We need connectivity when there are changes to be applied. So you can have your customer location part of this diagram can be disconnected at times, but once disconnected, everything will work in the state it was in from the last time it was connected. And as soon as these things connect back, it will go and evaluate whether the desired state has sort of been resolved on the customer location. If not, it will go on and apply that. So there are certain scenarios where people, if you have these things on a vessel, on a ship, where you might have, times with very bad connectivity, and then other times you have better connectivity, this can work fine in those scenarios as well. So the main scenarios that I want you to take away here is, make sure this is really about governance across your environments. It's a single management pane, and a single way of high-level Azure services to do great policy and management enforcement across all these clusters, nowhere where they run. And the other thing is the application management side of it, where it's very easy for you to go and get a desired state specified somewhere in a repository and go and have that deployed across a bunch of infrastructures and implementations in various locations. So I think this is. I'm still sorry. I got a little bit out of everything with the whole technical challenge at the beginning, but I think from a time point of view, I think we are sort of there. Is that correct?
Your time is just done, Mike. You can take a couple of minutes to wind up.
Okay, cool. Yeah, I mean, from my side, let me just focus a little bit on this. There is the public preview. You can go AKM as Azure Arc K8S docs. And we are also looking for what we call Azure Arc influencers. So people who want to get into a closer circle with the product team, be handed out, frequent and early bits in exchange of course, using these and having good use cases to give us some valuable feedback in terms of how we're doing on quality and the features that we've created. If you're interested in being part of the Azure Arc influencer group, then there's a sign up link here as well that I urge you to go and visit. I will stick around on the QA and chat for a little bit. So if there are any questions, there that I haven't answered, I can go and do that. I will stop sharing my screen now. Thanks for joining, everyone.
Cove.co